I start at 5 minutes. How to start your own self-driving car project, and everything of this with Python. So, and the goal of my, yeah, just a short history. So I presented this same talk, I believe, a couple of months in a local Python meetup. And so today in these 5 minutes, I'd like to plant a simple idea in your head that you can go, put your phone on your dashboard, start recording pictures and start recording videos, and like literally in 1 hour you can start to engineer your self-driving algorithm, and you can contribute to this area. So, and this self-driving technology didn't start yesterday, so it started almost 100 years ago. So that's the picture of the first radio-controlled car on the streets of New York City in 1925. So you're probably surprised that it has so long history. Why we want self-driving cars? So the regular explanation here is we expect it will save lives, and it will make transportation better and easily accessible, more efficient, more reliable, and more personalized. So everybody probably has this problem. Like you drive to your work, you're alone in a car. And then you take a trip with your family, and you need a minivan. So you need different cars for different purposes. So the regular plot with levels of automation. So probably many people have seen that. It's quite popular over the last few days. So there are 5 different levels of automation. And what we want full automation, level 5. And we are not there yet. So like Tesla or standard or other vehicles who has some autonomous driving capabilities, they are at level 2, and probably some share of level 3 and 4, but mostly at level 2. There are lots of companies investing in this area right now. So this is list, and there are not all of them. So it's always changing, moving. So you will see new companies coming, some companies go from this list, but that just demonstrates you how many people, companies work in this area. So this is very interesting and popular and very, very hot. So who will be first? Nobody knows. So you can start coding your own algorithm, and probably you will be the first who will make that level 5 autonomous car. Yeah, so there is a survey made by Lex Friedman. He is giving a course at MIT on self-driving cars. So he made this survey in, I believe, in his Twitter. And some people think it will be Tesla, some Waymo, but that's, I stole this slide from him. So he shows that list. So in 1998, that's the list of the people, of the companies working on the search in internet. There is no Google. So, and now Google dominates everything. So self-driving cars in Austin. So just recently Ford announced that they are coming to Austin, so in collaboration with Argo AI. So you will see more and more of these vehicles around the city. So, and at the same time, Waymo announced that they closed operation in Austin, although nobody has seen them for the last few years here. So regulation in Texas in this area very easy. So comparing to other states, we got good laws related to autonomous cars. So the requirements are just very simple. So you have to comply with all traffic laws. You have to be equipped with video recording device. So in case of some problems, so there is a history saved, and you have to be insured like a regular car. And this law is, so I learned that myself, that it prohibits local governments to regulate self-driving vehicles in any fashion. So the local community cannot prohibit you to drive your autonomous vehicle in their community. And because my time is almost over, so that's the main topic that I'd like to bring to you. So there are lots of public data. At least these 2 companies, Nuisance and Agraverse, they recently released open data. So it's labeled data that you can start using for your development. And so if you want, you can make a picture, or maybe I will share these slides later. So that's the code, everything written in Python. So, and data is available, and there are 2 papers where you can find all details. So, and that's very rich data collected in different cities around the world, and you can start analyzing them. And all that data is labeled. Like you see, there is a label box around that car, label around people. So that's the data that you can start using today to develop your self-driving algorithm. Thank you.
Well, thank you for giving me the opportunity. Oh, thank you for giving me the opportunity to talk here about one project that I have been excited about for a long time. Actually, I first started working on the project Euler back in, I think, 2005 or 6 when I first started to learn Python programming. And who in the audience is actually aware of Project Euler? Oh, so yeah, about 1/5. So it's this website, and you can create an account and sign in, and they have these math problems, and some of them are very interesting. I've learned a lot of very cool dynamic programming techniques. Oh, somehow it kicked me out. To sign in again. So this is the progress I have made. Back in, this was in 2007, I had all the first 152 problems solved. And only a few months ago, I started looking at the project again, and they have almost 700 problems now. And I looked at a couple of them. They're actually much harder, most of them, than what they used to be. And I found this very interesting problem that yeah, I just want to share that. So it's a lot of fun if you want to learn about programming techniques, and whenever you actually solve a problem, you can then go into the discussion forum for that problem and look at the solutions that all the different people have come up with. Okay, thank you very much.
Okay. Well, hi. When I signed up for the lightning talk today, I had one thing definitely I wanted to talk about because I'm here with Open Teams, but I had a bit of a dilemma. I mean, this is an open source conference talking about technical topics, and I've got my own little small open source project that I've been working on here and there, and I kind of wanted to talk about that too. So I was a bit torn, and I ultimately settled on I want to talk about the open source project. So this open source project, though, is related to a question, it turned out, that I asked myself recently. I was trying to figure out, if I wanted to write code on my phone, how could I do that? And that got me thinking more about what are the limitations? Like, what would make writing code on my phone difficult? Has anybody got any ideas? Keyboard, right. What else? What about the keyboard? Like, it's all the characters. What else would make it difficult to write code on my phone? No escape? Yeah, no escape key. Well, I'd have to say too much, right? Like, if I talk to you person to person, what makes that actually work? Context. We share information. We can assume things that are shared between us. So what if I want to have a conversation with my phone that ends up resulting in an application? Like, could I actually make that work? Well, it turned out, asking myself that question, I've been working on this little open source project on my own, by myself for a while, and I realized that was the answer. So first off, context makes conversations work. And now for a brief demo. So if we look over here, I want to write code. Here we go. I want to be able to write code that kind of looks like this for testing purposes, right? And I want to be able to say, given some condition, when I do something, then the expected outcome is this other thing. Now, the problem with this code, of course, is that, well, first off, like, how does result is know that the current value is 43? And how does value plus know that what I said before was 42, right? How do I pass that information around? And even then, like, if, let's say I could actually pass things around this way, how do I type check any of this, right? How do I know if the preconditions for value plus and result is are satisfied? Well, I thought about that a little bit. And I used a few libraries. I don't know if anyone's familiar with Cucumber, but Cucumber takes an approach where you build up these steps, right? And the steps will move data in, and they do this blackboard pattern of passing the data around. But it always bothered me that they lose the typing information, and they don't exploit the directed graph that results from composing the steps. So what I've done right now is made it so there's a way in Python to say, I've got this data that's going to be shared between steps, within some execution context. I'm providing the typing information, and I've actually made this work. You can actually run this test that I just showed you today. What comes next is the type checking, which I haven't done yet. So I'm going to issue a call today to say, I'd love help. I'm going to be implementing the MyPy type extension at some point, so you can actually know, will this test run, and is it type safe? So I named it LL step originally, and I called it that because it's like little logical steps, and I was having trouble coming up with a name. I couldn't figure out what I wanted to call it, and I've decided I really hate this name. This name is so boring, right? And it doesn't really make sense. So I started asking myself, well, what is LL step, or what is this project? Well, I'm focused on a type-safe composition of steps. It's a safety dance. So I'm going to rename it Safety Dance. But that brings me back to that dilemma earlier, which was that I had these two things I wanted to talk about, right? Co-founder of Open Teams, and I want to talk about that. Maybe I'm not just a co-founder. Maybe I'm a customer too. So we've got LL Step here on Open Teams, but I'm going to rename it, so let's rename it. And so I issued that call for participation earlier, asking folks to help me with type checking. I will recognize you on Open Teams if you contribute code, issue a pull request. So to summarize, create your Open Teams profile, sign up. I guarantee you're going to like the way you look. Thank you.
I don't have slides, so I'll just have to use me, I guess, as the entertainment here. My name is Roy Keys. I'm the head of data science at a company called Arundo in Houston. And I'm going to talk a little bit about how we hire data scientists. So you may have heard that there's sort of a scarcity of data scientists. From the data science hiring side of things, there is a glut of data scientists. So we have a very different problem and maybe a view on that issue. Quickly, for some context, we're a small, relatively small company building software for industrial customers powered by data science, whatever that means. And we are relatively unknown. Probably none of you have ever heard of us before this, but we still get a ton of applicants for our position. So typically we get 500 or more applicants for a single opening for data science. And that's sort of the situation we're faced with every time we hire. So basically, the basic message there is there's a ton of data scientists out there. Most of them are aspiring data scientists. You see sort of a power law distribution of their experience. And that's one of the things that we're trying to overcome with our process. So we want to have a efficient, effective, fast, and fair process to hire people. Let's see if I have my notes here. And what that largely means is that we want to spend sort of an inversely proportional amount of time on a candidate depending on what stage of the process they're in. We want to spend a very small amount of time on an early stage candidate, but we're willing to spend a lot of time on a late stage candidate that we think there's a pretty good chance we might make them an offer. So the way we're currently doing that, and this has evolved over the last few years of hiring, is the very first stage when we hire people is we basically send almost everyone to an online skills assessment. So at that point, we may not have even looked at their resume. And there's a couple reasons we do this. One is that just makes it very low touch, low effort for us, but also we think that's a lot fairer to do it that way. So before we're looking at anything, did they go to Hogwarts or whatever, or did they go to the community wizarding school? We're not screening at that point. We're going to send them to a test that's of basic data science skills. The other thing is that assessment that we give them, part of it is automatically scored. So the first thing then, the next part is we look, did they pass the threshold for the automatic scoring? And then the next thing is we are going to move to, if they pass that threshold, we look at a written part of the test, and that we have one of the data scientists follow a rubric and score. Then after that, we go to, and the HR takes over the next step where they do a phone screen. They'll look at the resume a little bit to see if there's, sometimes we'll get people that have a very unusual background, and then they might ask them some specific questions there. But generally, they're going to do a check of, can this person legally work for us? Do they understand that, where we are and some of the basic things that we think about? And then after that, we do a data science phone screen with a senior data scientist, and then eventually an on-site, and we go from there. And so far, that has been pretty successful. We've gotten some really great data scientists out of this process. And then the only other tip I'll add to this is that you should aggressively try to recruit people to get into this pipeline in the first place, especially if you're trying to go after specific groups of people. So that's my lightning talk on hiring data scientists, and I'll be free to answer questions if anyone has them.
Hello, everyone. Can you hear me? Yeah? Okay. So, yeah, my name is Alejandro Primera. So my background, actually petroleum engineer with about 15 years of experience in the oil and gas industry. So you may ask yourself, what is this guy doing here? So 6 years ago, I started a consultancy firm back in London, where we were tackling problems of reservoir engineering, like building numerical models and analytical models for different clients. And we use a lot of proprietary applications to solve those problems. So I ended up having a bunch of projects with a bunch of people that were not able to actually share the data or the knowledge among them. So in the past, I used to have a stack of applications that I used to use. And I started coding basically in C#. I moved to R. And I'm happy to say that a year ago, I moved to almost completely to Python without leaving some stuff in the back. But what I want to talk today is the experience that we have at the moment building a web platform for these needs, to actually satisfy the needs of consulting and actually providing some information of the projects that we're executing for clients. So anyone here using Django by any chance? And what about Vue for front end? Awesome. So I'm going to talk to you later on. So I'm actually looking for input here as well. So the platform that we have built so far, it's pretty much a web application where we're building a bunch of modules to solve some of the stuff that we have already done in the past. So we are reviewing projects, and we are implementing applications based on the projects and data that we have executed. Most of the projects are analytical projects. Some are numerical projects, but basically we are at the moment only 2 developers. And what I found is a lot of petroleum engineers that work with me in the past, they don't like coding at all. So I'm kind of the odd one out, but I found another friend of mine that it's very helpful, and we are actually building this whole platform. It's a Django web framework where basically we are using a cloud-hosted application for multiple users. We have a database in Postgres, and basically most of the templates and application, the front end, we are serving it with the Django templates. We are using a bit of Dash, Plotly, and on the other hand, at the very top, we are also using a bit of jQuery and JavaScript. So this is a bit challenging at the moment because we are growing, and we want to have interactivity in the application, but we don't want to lose all the benefits that Django brings us, like the forms, the tables, and so on. So we want to still retain those. And we also have faced some issues with some of the Plotly dashboards. And when I started to do front-end development, I found myself hating a lot JavaScript in particular. So just to show you very quickly what we have. So this is very nice. I can build up applications pretty much in half a day from scratch and view some of the data that I have in the database. But at the same time, when things get complicated with forms and so on, I'm finding more and more difficult to use Django and Python. And another thing that out of Django that we use, it's the REST framework. However, we are also finding that writing a lot of these APIs, it's quite complex, and we're finding some issues. So I'm going to show you some of the stuff that we do. And interactivity, for instance, we want to have a pretty responsive application. I don't want to go and click run to execute a jQuery and go back to the back end and bring some data to the front end. I certainly don't want to do that. And on the other hand, this is a Dash Plotly application that we have in place. And the issue that we have is that when we go and change data, we are really facing a lot of performance issues. It's taking, as you can see, probably 2 or 3 seconds. Yeah, doesn't look bad, but it's an issue for us. So we move completely, or we are moving some parts of the application to view. Basically, it's at the moment looking like this. Oops. So we have now part of the application in view. We are using a data storage. We are using a data storage in view where we can map the whole state of the application. What I found with Vue is that because it's so strict in the way that I have to code, I'm really liking more JavaScript. I know exactly where the code is placed. I can write my methods and for every components and templates, so the styling and so on. So my time is up, but if you want to chat with me, we can have a chat later on. Thank you.
Okay, can you hear me? Okay, good. Hey, my name's Chris. Currently, I'm a BI analyst over at Keller Williams. And currently, I'm also a student at the UT Data Analytics and Visualization Bootcamp. And so here, I'm going to present a recent project that me and my group recently finished that uses a lot of open source technology to create a full stack application or website. Basically our theme was, because we conceived it around Halloween, we decided, okay, let's pretend to be pirates for a little bit. And so we're a group of high-tech pirates that use data to determine, okay, where are the best places for lots of tourists for us to rob? And so we create an application that uses a lot of different tools. In the back end, we use a PostgreSQL database where we store our data in, which we store in a Heroku app, and that we pipe using the Python Flask framework to be able to produce this website. Real quickly about the data, it's only a few minutes. Basically, this is what the pipeline looks like. We have a bunch of data that we collected from multiple sources, including the UN, the World Bank, and a report that is released by MasterCard every year called the Global Destination Cities Index that reports the cities with the highest number of tourists and also the cities who spent with the tourists who spent the most money there. And we also included a lot of population data as well. Now with the population data, that one was a little bit tricky because with certain countries like the US, you only have a population every 10 years, for instance, right? It's not measured every year. But we decided to just do a simple interpolation technique to estimate the years in between what we were targeting, which were the years 2011 to 2018. And we kept it in the PostgreSQL database, which we host in a Heroku, piped over to Flask, and created this website, which I'm about to show you. So here's the website. It was created using HTML, CSS, and JavaScript. It's really nice, and we kept the pirate theme up pretty much consistently throughout the entire website. And one of my teammates, Nathan, did a really good job with this. So I really would like to thank him for that. And with each tab here, we have different views of the data. For example, we have maps that we created in Tableau and hosted and put it up on the website using the Tableau JavaScript API. For instance, this one here, which shows the tourist and expenses by city in this map. And you'll see that this map is also pirate themed because we use the Mapbox API, which has a pirate skin on it, because why not? Different views, income group by country was also included in one of our data sets, so we're able to show that as well, showing different patterns in the data. So once this loads, yeah, most popular tourist destinations year over year, just a simple graph in Tableau that we showed here, and that you can filter by year to include each year and the cities here on the right. We also included information from a report called the World Happiness Report. Again, it's the yearly report to see if there's any interesting correlations. For example, the correlation between happiness and other factors. And this one, happiness and freedom, not that highly correlated. But happiness in, well, GDP, money, that was much more strongly correlated. So with Tableau, you can create a lot of different visualizations, but sometimes you don't have as much control of it, right? So another view that we did was using a library called D3. It's a JavaScript visualization library. So, with this visualization library, we were able to create this bump chart to view rankings. Because in this view, I don't really care, about the total number of tourists so much. Every single year, I just want to see how they rank. For example, London gets the top spot quite a couple times, but Bangkok gets there, goes up there a lot. And tourism expense ranking, data is a little weird. Something could be investigated, but Dubai takes the top spot for almost all years. Tourism density, how many tourists are there per local population. Here, Amsterdam takes up the top spot for quite a number of years, then suddenly drops off and then is replaced by Phuket. And if I want to see more detail, I'll go to this Tableau visualization down here and see that, for Phuket, for every local population, there are 23 tourists there, which is really overpopulated. Yeah, and thank you so much.
Nice. Hey, thanks. My name is Brendan Collins. Thanks to all of NumFOCUS and all the folks organizing PyData. I'm talking a little bit today about some recent contributions to DataShader. There's been a bunch of really interesting developments in DataShader. DataShader is a general rasterization pipeline. So you can take large amounts of data, say a large data frame, and you can create an image out of it. And you can see certain structure out of big data, and that's what the raster format will give to you. Over the last kind of couple of months, some of the highlights in DataShader include GPU support that was merged and released yesterday, so some things to check out there. Also, Polygon support for DataShader is coming very soon. I specifically was focusing on geo tools for DataShader, and so I'm going to demonstrate some of the geo tools that are available inside of DataShader and specifically inside of the user guide. So these geo tools, you can think of these as raster tools. And to show and demonstrate some of the tools, I'm going to start by generating a terrain here. And I'm using Perlin noise to start to grab some data. I'm going to start looking at some of these tools. So the Hillshade tool will allow you to illuminate a surface, so you can decide on an altitude for a light source and a direction, and then you can take a surface and illuminate it. So here we're taking what is Perlin noise, and pretending that that's elevation data, and then projecting light on top of that surface. Datashader has a lot of tools in it. I'm specifically just talking geo because those are the tools that I tend to work on, but there's a lot to explore in Datashader. Slopes, so looking at terrain again and looking at the slope of the surface. Aspect recently also came out, which is the downward direction of the slope that's measured in compass degrees. NDVI, so doing vegetation detection on satellite data. So we have an NDVI function inside of Datashader now. Bump mapping, which is a cartographic technique that can be used for putting things like trees on top of a surface. So here, let's run some bump mapping here. If it comes out, you can kind of see now that terrain has these little green bumps that could be used for a cartographic technique for representing trees. Mean convolution filters that can be helpful for different cartographic techniques, but is certainly more general than spatial. And here we're putting together a full scene just based on some Datashader processing tools, which include like a coastal vignette and trees and elevation and illumination. We also added a proximity tool. And so this proximity tool will allow you to take any Datashader aggregate and generate a proximity aggregate based on that. So this would be showing the distance from any of the features in your aggregate as a surface. And that works with any of the Datashader aggregates. So here's an example of doing proximity off of a line. We also now support viewshed. Viewshed is the idea of what can I see from a specific location. So if you were on this terrain, and so here, we're trying to look at what pixels would be visible from an observer to a specific target. So an observer is a specific elevation above the surface, and then targets are different elevations. And it's essentially if we could connect any pixels in the image in a straight line without passing through any other pixels would be the definition of viewshed. And then we also have a zonal statistics tool now, which will allow you to do summary stats on zones inside of your images. So that's all part of the geography notebook inside of Datashader. So if you go to Datashader, and sorry, this is a little small, but if you go to examples, and then go to user guide, then you can find a bunch of these helpful notebooks here with examples of how to get started in Datashader, including this geography.
Thank you. Tyler Wen from Rundle Analytics. I talked about the open source package on anomaly detection early this afternoon on track 3 built by my team. And this is another open source package we recently also released called TSOG. It is a package to do data augmentation on time series data. If you're working on deep learning stuff for example, image, you're probably pretty familiar with all those idea of data augmentation. You have an image of a cat, and then you stretch it, you flip it, you add noises to it, you zoom in, zoom out, crop, and then you suddenly have 10 times of cat image. And when my team work on the time series task using deep learning, we thought we can find something similar and just use it, but surprisingly, we couldn't find a very good one online. There's a couple of them, but not really well maintained. So we're like, this is not something very hard to do, so we just create by ourselves and open source this very lightweight package. And so basically, we implement, I think, 15 of different kind of augmentation method, and for each of them, what you can do is that you input a bunch of time series, for example, this one with segmentation labels, and then you pick one of the augmentation method and you apply to it. For example, one of the very common one is random time warping. So I randomly warp the timeline of this 3 time series, and I get 3 new versions of this thing. And you can do this many times so that you get more data and your model is more robust. And of course, in practice, you don't really only need one augmentation. You may need to apply different kind of augmentation method at the same time. So in this package, we provide the API with operator plus, this plus sign, which basically say, connect this augmentation with this, and then you do this, and then you do this. Then you can just call this entire thing one time dot run, and you give X and Y, and you augmentate it one by one. And sometimes we also realize that you may need something like this. So for the first augmentation, I want to do it, let's say, 10 times in parallel, so that instead of a one-to-one augmentation, I'm doing a 1-to-10 augmentation. And in the second one, I want to do a time 5, so instead of have 10 different versions, I have 50 different versions, right? So we introduce this times signs to do this. And sometimes we also realize that the people may need to use something like, I don't really want to add jitter noise all the time. I only want to add it like 50% of time randomly. So we have this sign at. If you do at.5, then that means that this thing will only be run the 50% of time randomly. And so if we apply this to the original 3 time series, we'll get something like this, right? Immediately, your training set is more robust, and you can hopefully build a better model if you know how to do that. And of course, things can be getting too complicated that you don't even know what your pipeline looks like. So we have this dot summary to summarize what your pipeline looks like. This is basically very similar to what you will have in Keras if you use Keras. Yeah, so we open source this thing like basically the same time as ADTK, which is a package I introduced this afternoon. And I thought this thing could be more interesting to people because this is about deep learning, and there's a hype on deep learning, of course. And but surprisingly, the other package got like 300 plus stars within 1 month, but this one only got like 60 or something. And I feel this is a little bit underrated if it's not the other one get overrated. So I want to give a promotion to this thing again. And if you're doing time series deep learning, try this thing. And you can also, we'll also welcome you to contribute if you see anything. Yeah, thank you.
Hello. My name is Liliana Torres, and I'm part of the organization Women Who Code. And recently this year, we opened a new track that is called Women Who Code Python. And first, I want to thank NumFOCUS, because thanks to them, I'm here today. And they gave me a scholarship diversity accepted, and I'm here because of that. And I want to let everyone know that this organization is working globally, and we're trying to encourage more women to learn and to move in the IT careers. And we also want to make sure that everyone knows that you are all welcome to join us as long as you want to support that opportunity for women to grow and help them. We're always looking for speakers to help us online to teach this community. We do it different times of the day, and we are growing, and we hope that some of you can support us. And if you would like to talk more about it, we can discuss it later. Again, thank you.
So, Josh Schwartz and I are working on a project about unit standardizations, unit of measure standardization. However, this is not why I'm giving you this and this little lightning talk. If you go up, you'll see a poster, but not the ones you used to seeing a big poster. It's an interactive poster. It's set up like this. How many of you have ever seen people going with all sorts of large tubes on airplanes trying to get to their conference? Many. How many of you have actually presented posters in those conferences? Okay, this is a computer science conference, so you don't see those, but then you go to biology, you go to medicine, you'll see hundreds of those posters. Each one of them cost about $100 to print. Here's a picture from me from the NIH. The poster next to me probably costs around $100 to print. Today, I can get a machine in less than $100. And then I can present a poster like this on it. And the setup you'll see upstairs tomorrow. So you no longer need to print the paper. Think about those 80 posters or 100 posters out there not having to be printed. Think about only the saving that money, and I'm not talking about the hassle of actually going and printing up and taking and carrying the tube on the airplane and then figuring out what to do with the poster afterwards, because you now have it in an electronic form. In electronic form, you can do other things. You can show pictures and talk about whatever you wanted to talk. You can have links that if you click on, all of a sudden things will appear to whoever you're trying to explain. I'm talking about some machine learning issues, so I can actually show this. And I'm able to do this just because the PyVis team or the HoloVis team was able to create those tools for me. What you see here is actually a static HTML page. Whatever is dynamic is already embedded inside. It's like a document. You can send it to people, or you can give them the link on the internet and they later can download it. You can do things like saying, okay, here's a zoom out problem of what I'm talking about. And this is a machine learning problem. I'm showing lexical proximity. You can actually see what proximity is between two units. But then I can show them, oh no, this is how it really looks like. This is a 25,000 by 25,000 approximately size matrix. You cannot even think about that size. But PyVis can actually show it and you can explore how it looks like. But then I can show it to you before machine learning, after machine learning, and you can see the difference. And all of this can be done in one poster. You cannot show it on paper easily. You can have papers explaining your processes, tables explaining your processes that you use. You can show results of multiple neural networks and show how accurate they are. So this is supervised learning, and you can show it, oh, once I did it with this type of architecture, that type, and you can see how it changes, and you can explore deeper, deeper and deeper. All of those things are possible using the PyVis tool. This is specifically HoloViews. The envelope of what you see is panel. Panel allows me to do those switches. This is specifically the plots are HoloViews. And for those of you who know, it wraps bokeh, matplotlib. And for those who are doing machine learning, many people tell you machine learning, well, it's like a black box. You can't look inside the neural network. Oh, yes, you can. Look at this. This is a neural network during training. And using PyVis tools, specifically HoloViews on top of data shader, we can actually see how a specific neural unit within the neural network changes through time. This is time. Those are the neural units. And you can do this for different types of parameters within one layer. You can show multiple layers in this way. And this is how you can explore all of your results. To summarize, I used PyVis tools to show this. If you're interested in learning more about the project, come tomorrow and the poster will be out there. But you can download it now. It's on the web. It's one document. And of course, you can add in whatever links to whatever publications you had before. All of this is actually static, but it is dynamic when you actually go and hover things over it. So stop printing paper, start using PyVis.